Good day, everyone. Um, this is the presentation of lecture notes, chapter 1 for MEC400, Introduction to Engineering and Problem Solving. So, engineering has came a long way from the invention of the wheels, for example, up to the supersonic flights, uh, gigantic structures, and whatnot, through the evolution of science and technology. So, this course as a whole is intended to introduce engineering as a framework for development of product or processes and system building. And not only that, but to also to introduce the essential personal and interpersonal skills, soft skills that are expected um, of an engineer. Okay, let's move on to chapter 1. The title of chapter 1 is Engineering Profession, and this particular video will cover some parts or some topics in this chapter 1. All right, the remaining topics will be covered in the next video. The first topic in chapter 1 is to introduce to you a concept called CDIO, which is basically a international project by engineering lecturers and professors. It's a framework actually in which students are put into an environment that is conducive in the acquisition of knowledge, skills, and attitude, okay, essential to freshly graduated engineers. The CDIO stands for Conceive, Design, Implement, and Operate. In the subsequent slides, I will explain these ideas. So, beginning engineers or fresh engineers should be able to observe the CDIO concept, okay, in designing engineering products, adding value to existing engineering products, besides designing and developing processes and systems, okay, in a team-based environment, okay. You might notice the word modern team-based environments in this slide. The word modern is used to emphasize that the field of engineering, just like any other fields, is expanding, is growing, okay, beyond the traditional borders. So, group work or teamwork, okay, is very essential, okay, now and in future, okay, to work in engineering projects with several members in it. Not This is not a one-man show anymore. So, engineers should be able to participate in engineering processes, contribute to the development of products, as well as be able to work in organizations effectively. Okay. So the CDIO as an initiative has three overall goals. First is to master the deep working knowledge and the fundamentals, which you are going to go through, okay, during this 4-year program. You're going to acquire as much uh, as possible the knowledge and fundamentals of engineering theories. Followed by the second objective, okay, is to lead in the creation and operation of new products, process, and systems. You will realize time and again the mini projects and projects, including final year projects, okay, throughout this spread of 4-year program, is intended to train you, okay, to be able to develop new product, process, or systems, or have sufficient knowledge to understand existing engineering products, systems, and processes. The goal, overall goal, ultimate goal is for you to be able to create your own product. Okay. Um, and the final goal is to understand the importance of technological development on society. Okay. 10 years ago, 20 years ago, okay, the impact of technology on society is not seen as it is seen and enjoyed by the society today and deep into the future. All right. Every aspect of human life is going to be affected by technology, and technology means application of science in which engineering is part of it. A bit on word-to-word definitions of conceive, design, implement, and operate. Conceiving is basically coming up with ideas, all right, based on customer needs, all right. Whatever that we create or design and develop should be aimed at improving human life and the environment, which includes other forms of lives, okay, and objects. So we have to consider what is the existing technology, whether there's a need for development of technology for customer needs, how cost effective and what are the cost benefits in terms of enterprising it, and the development of technical and business plans. So this is at the conceive or conception or conceiving stage. The designing would be putting pencil on paper. So basically creating the design, right? This does not mean it is confined to engineering drawings using softwares or on paper itself. It can be even a process design, right? And algorithms, formulas, okay, or computational tools that we develop, okay, to implement the idea. So the implementing the idea is what is actually called design. It is design does not necessarily mean the geometrical feature, the color, the material type. Okay, it includes that as well as how a product or process is intended to function. That is the meaning of design. So to design, you really need fundamental knowledge. Third is to implement, that is to transform the design, okay, in whichever form it is, on paper as a drawing, in software as a drawing, or in as a simulation. You have to transform it into or manifest that into something physical that is really working out there. So this includes, okay, testing and validation of the product, process, or system. And finally is the operational part. Okay, an implemented idea out there, okay, is worthless or meaningless without someone operating it, using it, and operating it. All right. So these are the four stages in CDIO. We move on to the second topic of first chapter, that is soft skills. All right. So basically, the 4-year program, okay, which I always think as a training program for engineers. You all are engineers in training, to develop the creativity, okay, in whatever that you're doing, right? And notes taking, okay, as a student, one of your main job is to learn, all right, and what more in ODL, this challenging times, okay, self-learning or self-centered learning, okay, can't be overemphasized. It's getting as part of the daily routine. So within this self centered learning, all right, notes taking is a very important skill, I would say, and you can start to implement creativity there, all right, and subsequently creativity at everything that you touch and do. For example, you're going to do you're going to embark on the assignment, okay, on the practical work as well as the project in this course, MEC400. The cover page for the assignment that you're going to submit, okay, can be as creative as possible, okay. Having said that, and before I forget, let me remind you that you're not supposed to use UITM logo on the cover page of any submissions for any courses. UITM logo or the usage of the logo is subject to approval, right, of the UITM management. So try to avoid using the UITM logo. Other than that, coming back to the creativity part, okay, show as much as creativity as possible. And I'm not telling that it has to have a um, flowery images or what, but um, other than that, okay, outside normal creativity scope. So that is one. The second is the time management. All right, it's very, very important. One more in the online learning environment. Um, like now, right now, you are listening to this video, watching this video at your own pace, all right, during and including outside class times. So, I believe you're taking more than one subject, obviously, and you need to manage your time well. You need to know when the learning process has to take place, when you need to sit down and start working on your assignments, tutorials, and whatnot, and when to put the pencil down, okay, conclude whatever you're doing, so and submit it on time. All right. So this is a very important part of time management, especially as a student. You're always going to face deadlines, so you must know when to stop. Whether you finish the given task completely as per your satisfaction or not, there's a deadline that you need to honor and respect. Secondly, the efficiently and in a professional manner, you have to communicate plans, results, thoughts, and all that. So this will be covered in detail in chapter 2 in engineering analysis. All right. And thirdly is the ability to work in multidisciplinary teams. This is one of the skills. All right. um, we humans are of different nature, all every one of us, each and every one of us, and working in a team can be challenging when it comes to interpersonal interactions. So how are we going to manage people, okay, and the team members? All right. How are we going to manage disappointments? How are we going to effectively communicate those disappointments to the members, and extract work so that distribution of work is fair and even. All right. To lead a team or to work in a team, okay, is actually a skill. The third topic, engineering as a profession. What is engineering? Okay, I leave this for your reading. Okay, I'm not going to read it out as a news, but in simple words, engineering is basically problem solving. That's all. Problem solving. All right. So, what does engineers do? They solve problems. Therefore, mm, another plain term for engineers or is problem solvers. All right. So basically, engineers, graduated engineers, and those who are already in the field, the practicing engineers, all right, are well respected as problem solvers, and they have been absorbed. Okay, there are tens and hundreds of examples of engineers getting into major businesses, decision making, big management positions or managerial positions, and so on. They don't necessarily stuck in the technical work alone as they progress in their career. Why? Because essentially, at the fundamental level, engineers are problem solvers. Give them a problem, they will analyze it, okay, or resolve the big problem into smaller ones, analyze it, and try to prescribe the right tool, method, and solution, okay, to solve the problem. All right. So the main aim of an academic engineering program like you are in right now is for you to learn the existence of tools. That is most important. It is not about memorizing formulas and all that. It is part of that, yes. Okay, you will also be facing tests and exams for this and many other courses to come. All right. So obviously, you really need to know the theory and how to use them and all that. But to know the existence of concepts, okay, and ideas, formulas, and theories is very important, because these are the basic tools that you need to start with whenever you are given a problem. To implement the tools, for example, if it's going to involve calculus, all right, out there while you're working, you can always get the advice, or a mathematician, all right, can always consult you on the problems that you're facing. The thing is, you need to know who to refer to. Okay, similarly, tools as well. Okay, what tools are there out there that you can use to solve a given problem? Whether or not you by yourself is an expert in using the tool actually doesn't matter. All right, but you need to know how it works. But you can always get the assistance of a technician or a technologist to make it work. So basically, engineering is a problem solving business. um, I already touched much of what is to be said in this slide. Okay, so engineers are problem solvers. They apply science, math, and beyond that, a good judgment. Okay, in selecting the solution. Sometimes you have more than one solutions. Okay, so which one benefits the society the most, which one is the most cost effective, all right, also comes into the role of, or the function of, solving a problem. So you solve a problem to make things work better, more efficiently, faster, and cheaper. Continuing on, engineering as a profession. So your skills in communicating, in critical thinking, and managing tools and people to find practical solutions that benefits the society, okay, is part of being an engineer, okay, or operating as an engineer. So what engineers do in the strict sense of engineering products, they design, create, build, improve, invent, operate, okay, implement everything. Okay, uh, just take a look at around you. Okay, you will see machines, devices, equipment, appliances, everything. Almost 90% of what you see around you, okay, somewhere along the way an engineering input was there. Even the wooden table across you, all right. So here in this slide, okay, we go up to the art valves, okay, artificial art, to microchips, to civil structures, okay, skyscrapers and automobiles and space vehicles, all right. So I leave it to you for your own reading. The desirable characteristics numbered 1 to 8 on this slide. Okay. So take note of this. You may need this list of characteristics to be associated with the assignment that you're doing on the job advertisement. Engineering disciplines, okay. Initially, the first discipline, engineering discipline, is said to be civil engineering, uh, for to fulfill the demands of medieval wars, okay, and the modern wars. And from civil engineering, okay, came mechanical engineering, then electrical, electronic, chemical engineering, and today it has grew to a long list, okay, part of which you are looking at right now, okay, from aeronautical to the, or the at the top left, to petroleum engineering at the bottom right, okay. So I leave it to you for your observation on this slide. And within each discipline, okay, which in this case is aerospace, okay, you have areas of study like aerodynamics, propulsions, flight dynamics, okay, and of course structure and materials. In chemical engineering, okay, among others, we have food processing, biochemical, and polymer plastics, okay, designing the microstructure or structure, okay, of polymer plastic at the structural level, microstructure level, and bring it up to the physical or the macroscopic levels. In civil engineering, we have construction, transportation, geothermal, structural, environmental areas, electrical engineering over here, and our mechanical engineering, all right. The areas in under mechanical engineering also is growing. What you're looking at is not exhaustible. There are more than these areas right now, okay. Thermofluid, solid mechanics, mechanical design, dynamics and control, okay, systems, which now more or less comes under what is called mechatronics, and of course materials engineering. So, mechatronics, for example, is the overlap of several other areas and fields. Okay, it's a marriage between mechanical engineering areas and electrical, electronic areas. Okay, as you are seeing right now, mechatronics, it includes mechanical systems, electronic systems. Okay, computers for the control systems. Okay, you put all this together, you get an area. Okay, an hybrid area, a composite area called mechatronics. All right. Similarly, biomedical engineering is an hybrid engineering area. So these are areas or domains. Okay. Right now, besides MEC400, I'm also teaching vibration. I have been teaching acoustics, which is not offered this semester as an elective. Vibration is a core subject which I'm teaching as well. These are the other engineering, mechanical engineering disciplines. Okay, so I leave all this long list for your own reading and appreciation. Um, this might be the last slide for this part of the video for chapter 1. So engineering functions, okay, please take note. Okay, these are important functions that you need to know. As an engineer, you will be involved in design and production, as I've been mentioning earlier, under the CDIO. As you grow in your career, you will be also probably involved in R&D, research and development. You probably will involve, okay, in the functions of sales, management, consultation. Okay, so it is not strictly on engineering product only. Okay, so outside the conventional engineering domains and areas, you would also be involved, okay, as sales, in management, okay, in business startups. Okay, so engineering functions goes slightly more than the core. Or like me, you would be also you may be also functioning as a teacher or lecturer or professor. So with this, I would end this first part of the video and see you again in the second part.